A sequence is an ordered pair, like a pairing of numbers, or like a group of numbers, and there's some kind of pattern that makes all those numbers relate. Okay, right here, what you see for this first example is a rule. Is a rule to find all those numbers. They also call this the nth term, which we'll see in a minute here. The weird part is the n. It's not like a normal variable that like what you guys are used to. The n is telling you what number, like where that number is in the sequence. So let me show you. Here's a good illustration for it. So this number right here is a sub 1. This is a sub 2. This is a sub 3, and 3, and this is a sub 4. So this right here is going to be our first number. This is going to be our second number, third number, fourth number, and so on. Now I'm only going to 4 because it only asks for the first 4 terms, and so this is how you would find it. A sub 1 would equal, now what I'm going to do is I'm going to take this rule and I'm going to plug the 1 into the n. So it's going to be 3 times 1 minus 2. And what is 3 times 1 minus 2? 1. That's 1? Okay, so I get 1 right there. So 1 is the first term. A sub 2, you go 3 times 2 minus 2. See, not bad, right? This is pretty simple. You're just plugging and chugging stuff. And so that would be 6 minus 2, which is 4. And then a sub 3, I do the same thing. Oh, that's a weird equal sign. So 3 times 3 minus 2, so that would be 9 minus 2, which is 7. And then we have the last one, a sub 4. 3 times 4 minus 2, so that's 12 minus 2, that'll give you 10. And it goes on, but we're only doing the first 4 terms. And so the sequence that letter A is talking about is 1, 4, 7, 10. And it goes on. Okay? So what would, do you guys know what the next one would be? 13. It looks like it just increases by 3 each time, right? Okay? Now, there's other ways you can write the rule. You can write the rule recursively, or you can write it like this. Now, I like this way the best. It's not as confusing as the recursive way. I'm going to introduce that way to you guys, but it's not something that we're going to go extremely deep into. This is not a number theory class. Okay, so the next one, it's slightly different, and the reason why it's different is because of this guy. The n is now an exponent. So let's go ahead and write up our things again. We have a sub 1, that's our first term, our second term, our third term, that's a weird a, and our fourth term. Okay, so to find our first term, we would plug the 1 into the n, so we have 3 plus negative 1 raised to the 1 power. That's going to give us 2. This is a neat one. And then I plug in a 2, I get 3 plus negative 1, and I have a 2 right there. What is negative 1 raised to the second power? 1, so it's 3 plus 1? Yeah. Okay, so I get 4, right? Because it would be 3 plus 1, because negative 1 raised to the second power is positive 1. Now a sub 3 would be 3 plus negative 1 raised to the third power. What is negative 1 raised to the third power? Yeah, it would be negative 1 times negative 1 times negative 1, which would spit out a negative 1. 3 plus negative 1 is? Oh, we're back to 2. Huh. What's the next one you think going to be? Yeah, you're right. If I plug in 4, negative 1 raised to the fourth power. Now, because the power is even, negative 1 is going to be positive, and so I have a positive 1. We're back to 4. And so, what's the next number going to be after that?
2.
Yeah, it's going to go 2, 4, 2, 4, 2, 4. That's kind of weird, huh? That the sequence would just kind of repeat itself like that. Now, why is that? Now, why is this one different than the other one? The other one, it doesn't repeat itself. How come this one repeats itself even though I'm plugging in different numbers? Yeah, because it's an exponent. The n is that exponent. It's raising a negative 1 to an exponent power, and that's why it just kind of does that. It's kind of neat. You start recognizing these patterns and being able to do them in your head and finding them really fast. Okay, let's try another one. Or another type of problem. Now this one's gnarly. It has a lot of stuff in it. It's a fraction, but same idea here. Except n is something that you multiply, and it's an exponent. So when I plug this in, let's see. I get a sub 1 equals negative 1 raised to the 1 over 2 times negative 1 minus 1. Okay. So negative 1 raised to the 1 is negative 1, and on the bottom I have negative 2 minus 1. What's negative 2 minus 1? So I have a negative 1 over negative 3, which is positive 1/3. Okay, so over here I'll write my stuff. Here's a sub 1 equals, a sub 2 equals, a sub 3 equals, a sub 4 equals, because it just asks for the first 4 terms.
Why is the one a negative?
Why is which one negative?
The one, the first one, the 2.
Oh, this one right here? Oh, that shouldn't be negative. Oh, thanks for finding my mistake right there. Okay, so that might change our answer. Yep, that's a positive. So now I have a 2 minus 1, so that's not a negative 3. That's going to be a 1, right? So what's my answer going to be? It's just a 1. Good catch. Oh, negative 1. Thank you for finding my mistake. All right, so I have a sub 2. So my second term, I have negative 1 right there. I plug in a 2, and then underneath that I have a 2 times 2, and I'm subtracting 1. Okay, so that's going to be a positive 1 up top, right? Negative 1 times negative 1 is a positive 1. Then on the bottom I have a 4 minus 1, which will be 1/3. Okay, yeah, so we have a 3 on the bottom. So this is 1/3. Okay, next one, I have a sub 3. I plug in a 3. That's going to be negative 1 raised to the third. 2 times 3 minus 1. Negative 1 raised to the third power is going to be a negative 1. And then underneath that I have 6 minus 1. So what's 6 minus 1? 5. So I have a negative 1 over 5. Sit down and make me nervous. Negative 1 over 5. Okay. And then what's my last one going to be? You guys want to take a guess? Oh, you think it's going to be 1/7? You think it's going to be 1/8 or 1/7?
1/7.
Oh, you're outnumbered, Hubbard. Okay, let's see. Negative 1 raised to the 4th over 2 times 4 minus 1. So negative 1 raised to the 4th is positive 1, and then we get 8 minus 1, which is 7. Good job. So I have 1 over 7. Okay, now what's interesting about these? Oh, it's kind of decreasing, right? I wonder what this graph would look like. Like if I were to graph these, you guys know what this graph would look like? You guys want to see it? Okay. Now this graph is interesting. One, because it looks like the numbers are decreasing, but decreasing isn't right to say because isn't negative 1/5 bigger than, like it's greater than 1, negative 1, isn't it? It's greater than negative. That's so. They're not, you can't say that they're decreasing. What are they doing? They're getting closer and closer to 0. They're getting closer and closer to 0. So if I graph this, let's see what it looked like. Now your domain is going to be your n. Okay, so this is 1, 2, 3, 4. Okay. Now for we'll make this a positive 1, and we'll make this one right down here negative 1. Okay, so if I have a 1 for the n, I get negative 1. So I'm down here. If I plug a 2 in for the n, I get positive 1/3. So that's right here, right? Right? Okay. If I plug in a 3, that would be a negative 1/5. So that's about right there. If I plug in a 4, I get 1/7, which is right about there. So it does this thing. It's kind of interesting, isn't it? You don't think that's interesting?
Will it eventually, like, it's level off?
Will it? I don't know. That's stepping in the realm of calculus. Okay, you guys will get more into that next year.